This six-story structure isn't a factory or workshop. It's actually the engine room of the world's largest LNG-powered container ship. The space inside is so massive that workers can literally walk around in it. This giant engine drives a propeller as tall as a two-story house. And obviously, an engine of this scale consumes a massive amount of fuel. How much? It gulps down nearly 100,000 liters just to start. Its fuel tanks are so huge that you could fit 6 Olympic-sized swimming pools inside them, storing up to 20 million liters of liquefied natural gas. Today, you'll see how one of the most extreme engineering projects on the planet was built, a project that genuinely pushed human capability to the edge. Welcome back to ZIMVOIC. Even though we live in the 21st century, nearly 90% of international trade still moves by sea. Whether it's something tiny like a needle or something as massive as cars, almost everything travels through the ocean. To get an idea of the scale, look at Flightradar. Around 15,000 to 20,000 airplanes are in the sky at any moment. Compare that with marine traffic. Right now, roughly 38,000 cargo ships are moving across the globe. We humans have already built extremely large ships. Even larger ones could be made, but then they wouldn't fit through major sea routes like the Suez and Panama canals. So the goal today isn't just size, it's fuel efficiency. That's exactly what the French shipping company CMA CGM aimed for. They wanted to build the world's biggest eco-friendly cargo ship, powered not by diesel or heavy fuel oil, but by LNG, liquid natural gas. This ship is 400 meters long, roughly the length of 4 football fields placed end to end. It is 61 meters wide and taller than the Qutb Minar. Fully built, it weighs as much as 7 Eiffel Towers or 11,500 African elephants, around 70,000 tons without any cargo. It can carry 23,312 containers. And if you lined up all those containers in a single row, the line would stretch for 150 kilometers. But the real challenge wasn't building just one ship of this size. CMA CGM needed 9 of them, and all within just 2 years. A massive Hong Kong shipyard, 4 kilometers long and operating like a miniature city, took on the job. 6,000 workers from across the world worked there day and night, each handling specific tasks. Normally, one ship takes around 18 months to finish. So how were 9 completed in 2 years? The answer: build them in sections called blocks. The foundation of each ship is made from steel plates coated to resist corrosion. One ship required 12,660 steel sheets. These sheets were cut with a special laser beam heated to an incredible 18,000 degrees C, 3 times hotter than the surface of the sun. It sliced through steel like a hot knife through butter. In total, 880 kilometers of steel strips were cut for one ship. These sheets were welded into blocks, some room-sized, some as tall as multi-story buildings. Most blocks already had wiring, pipes, and fittings installed. The rear section of the ship alone was built from 5 giant blocks and weighed 790 tons, equal to 2 locomotive engines. Just lifting, it required 2 massive crane units working together. Even a 1 millimeter misalignment could ruin months of work. Once the blocks were placed, endless welding started. Shockingly, a single ship required 1,250 kilometers of welding, enough to stretch from Karachi to Lahore. Each weld was inspected carefully because the ocean doesn't forgive weak joints. All of this only completes the hull. The real marvel is the engine. This ship runs on LNG, not traditional oil. LNG emits 99% less sulfur dioxide, 91% less air pollution, and 20% less CO2 than regular marine fuel. A huge environmental win. But storing LNG is the real problem. It must stay at 161 degrees C, or it turns back into gas and expands violently. So they needed an enormous fuel tank that could keep LNG ice-cold, even on a long trip from Asia to Europe without refueling. That led to the creation of the largest LNG tank ever built, 18,000 cubic meters in volume, large enough to hold 6 Olympic pools. Building this tank took 9 months, Multiple layers of insulation were installed to keep heat out. Leak testing was critical. Workers applied soapy water to the joints, covered them with glass containers, and used compressors to pull out the air. If bubbles formed, the joint was leaking and had to be repaired. After testing, the final membrane, a special 1.2 mm steel layer, was added. At cryogenic temperatures, it contracts and expands without cracking. This exact technology is also used in space stations. After 8 months, the world's largest cryogenic thermos was complete. Now the engine, the biggest natural gas engine ever built. It stands 20 meters tall, like a 6-story building, and weighs over 2,000 tons. It produces 85,000 horsepower. The maintenance crew can actually walk inside it. Transporting the engine to the shipyard was another engineering challenge. It arrived in 6 parts. The most important part, the crankshaft, weighs 220 tons. It was moved using a 140-wheel remote-controlled platform and installed with millimeter-level precision. This engine uses 12 pistons, each a full meter across. Its 92-ton propeller, cast in one solid piece, is 10 meters tall. The alignment between the propeller and shaft must be perfect to avoid dangerous vibrations. Engineers used a blue dye test to detect high-pressure contact points and fix misalignments. Once the ship's body and engine were complete, it needed protection from the sea. Saltwater, waves, and friction can chew steel apart and increase fuel burn. So the entire ship was coated with special paint, about 1 million liters of it, covering over 9,500 square meters, twice the size of Vatican City. The last piece installed was the command bridge, the ship's brain, where the captain controls everything. A Smart Eyes system gives a full 360-degree view around the 400-meter vessel. After 1.5 years of constant work, the first ship, Jacques Sardet, was ready. It then underwent 15 days of intense sea trials, engine speed tests, emergency braking, navigation checks, and full structural inspection. Even the anchor was tested. A single chain link weighs 300 kilos, and the entire chain weighs as much as 60 elephants. The ship passed every test. The dream of building low-emission megaships became reality. One after another, 9 identical giants were delivered on time. This isn't just the story of building a mountain of steel. It's the story of thousands of workers using their skills and determination to bring a monster ship to life. These vessels are now ready to rule the oceans, cleaner, stronger, and smarter than anything before them. It proves that when humans decide to push limits, even massive steel giants can be made to conquer brutal seas. We hope you enjoyed this ZIMVOICE video. Don't forget to like, share, and leave your comments. See you in the next incredible